Imagine that if you're a translator, we have here Rodrigo. He's a translator that's working in, for example, on composite laminate research. And he recently joined a team that is using OTE to work this open translation environment to do their translation. So given a new task by a client, he wanted to look into prior experiment data that's being produced by the team. But all of this now is ontologized. It is now within this knowledge base, the powerful knowledge base. However, he is not an ontology expert, and therefore, he doesn't have the expertise to start directly working with ontologies. For example, how to query the data, how to get the data out of that. How can we help him to work further with this environment? Here is where the exploratory search system can help. But before that, just to introduce the agenda, this is what we are talking about today. We wanted to know a bit, or want to introduce a bit about what is the exploratory search system, what are the key features that we develop for this context. Also, we look into the innovation cases that's being developed for showcasing how this ESS or exploratory search system can be used. Afterward, we will look a bit, not too much, about the architecture and technology that we are using to develop this system. And the last one, in case that you're already interested and want to try it out, we also already provide with the guidelines on how to set this up in your innovation case, for example. So let's start. Everybody of you should already know about the traditional search system, something that's rely on this really popular query response paradigm. And this is really successful to be used in the, for well-defined information search with a precise goal in mind. Let me ask you, how many of you that already use search system today? So almost all of you. Probably some of you already like online, probably already do it now to search about what is exploratory search system. So this is clear. When you have something in mind and you wanted to know about what it is about, then this is something that you would like to use. But it's not always the case. There is also some times where you actually wanted to have, you want to be able to explore data that you have. You don't really have a specific goal in mind, but you wanted to explore in a way to learn something or to investigate something. In this case, the interaction between the user and the system is more, how to say, dynamic. You can go back and forth. You can click on certain links, going somewhere forward, going backward, looking for something else, and so on and so forth. And this is where this kind of system, like a different type than the traditional one, actually came into play. In essence, it's provide a more active engagement in the search process. In general, again, it's not like you are using for specific information, but it's to add knowledge to the user, like Rodrigo does. He probably already know how to do it, but he wants to add knowledge into what he has to do the work that he needs to do. Just to provide you with a context, the exploratory research is not limited to knowledge graph or ontologies. You can also use other type of data structure to do such exploratory research system. But if you're doing it on the knowledge graph, for example, based on the emo ontology that I already explained before, you can make use of the structure of the knowledge. In here, for example, let's say that you're explaining person, Leonardo da Vinci, who actually painted this Mona Lisa picture. If you have the semantic structure behind, if you have an ontology describing how person and the object that he or she created as a background, as you see on the right side over here, then you can make use of it to allow for more interactive process in exploring such knowledge. For example, you can browse through the person, and if you know that in the structure you have the relation between this person with the, in here, I think like a person, it has certain kind of image, and it also provides a relation between the person and the document that or any kind of work that he or she has created. This is just a small example how you can browse through all the links that have been provided by the structure to get into the information to add into your personal knowledge. So that's more or less like a crash course into what is the exploratory research system. And now we look into what we did inside of the project to provide an exploratory system, especially in a knowledge graph, to help translator in doing their work. First, we focus on the semantic and rich data exploration, basically making use of the structure that you have. At first, you have this standard keyword search. This is something that all of you know, and this is a good starting point when you search for some object. For example, in this case, I have example of a pre-printing. You can put it in the search box inside of the ESS, and you get some results. On the right side here, you have the information contained within this object. For example, for all type of pre-printing, you have number of properties. For example, the input resin, fabric, method, and so on, plus all the information about the materials that's being used inside of it. This is all based on the semantic structure that it has. Further, by calculating the information that you have inside, you can try to find or suggest to the user, like what could be related object to the object that you have found there. In here, we suggested like a number of other objects that are similar. For example, base that it have the same class or same properties or any kind of relation that you can make. One important thing here is that the algorithm to suggest you what are relevant can be customized. So this is just one way to do it. There are different ways to do it, and you can integrate it as part of the ESS. And you can decide whether you want to do it on the fly or pre-calculated. It's really up to the use case, whether you want to have a fast response or a better response, for example. Another thing that we make use of this semantic is this search result categorization. So you can add already in the user interface what kind of classes that are, how to say, like the main classes that you can put to filter out results based on specific type of object. Again, this is customized, so you can do you can configure it as part of your instantiation. In general, this is something that we have as a whole, where you actually allow to do this result visualization contextualized by certain filters, certain structure of the class. Even, for example, you can make like the info box on the right looks different for each of the classes, or even for one single properties where it contains some number. For example, if you have to make a visualization out of it, it's also possible. This really powerful customization mechanism that we have here. The second thing is that we look into more manufacturing specific paradigm. We are talking about with some stakeholders regarding what they need with for this kind of system. And we actually published it as part of our paper that we published last year, where we see that there is three main requirements that's coming from manufacturing stakeholders. The first one is this multi-perspective exploration. Means that depending on your role, the role that you have inside of this process, you might want to have different kind of visualization of the data. In here, we only have two, like guest and translator, where the translator will have more in-depth knowledge about what is inside. So we are providing them with this capability to filter the data based on what they need. But guests, for example, we assume that they don't really have the background on that. So we only provide two visualization. The second one is hierarchical browsing. Probably already seen in EMO that actually if you look into it, it's the class hierarchy. It looks like a tree where some stakeholder would prefer to browse through that. So instead of like searching by keywords, they wanted to focus on certain class and look to the instances of that class. So in here, we're providing you with a set of class hierarchy. When you click on one, and it will do search specifically on this class and get the result only coming from that one. Okay. The last one is the provenance visibility. Currently, this is not implemented, but what does it mean is that for each of the data, for each of the instances that you have inside, you will know where does it coming from which file. Depending on what kind of user authority that you have, you may be able to go to that file to find the source of the instances that you have within specific data that you see in the ESS. So that was the two main things that you can see inside. Other feature that we implemented as well is the user authentication. So this is something that we is to make it compliant with the other part of the OTE, as well as to provide some kind of security layer to the ESS. Other thing is that multilingualism. Depending on what kind of data that you have inside, you can actually switch language. In ontology, it's possible that you add different label to each object. Means that you can have a different name in different language, one in English, one in German. And if you have it and we configure it in the user interface, then you can do switch. And then all the label inside of your data then will be switched to this different language. Statistical information is another thing. So in here, currently, we only have the basic thing like number of classes, instances, triples, and so on and so forth. But we can add this with additional information as needed for each of the use case. The last part, if you dare enough, you brave enough, and then you know enough of the data and the ontology, then you can write directly your SparkTalk query in there to get the result, to make a full use of the inference engine that is provided by the ontology and knowledge graph. So that's more or less it. Like the key features. Of course, there are a lot more that I don't explain today. But if you're interested, feel free to contact us about it. Regarding the innovation case, let's get back to the problem of Rodrigo. Right? He wanted to do some translation. Also, before that, there are a few systems that is currently online. This is some of them. We have two that we will use for the for this workshop. The first one is the Rodrigo case with the composite. The other one is alloy precipitation, which will be explained further by our colleague from Sintef. And for example, we have another one which is not directly related, but this is about documentation of the robots within the TUWIN pilot factory, which also accessible, and many more. Okay, Lo. When we are talking about Rodrigo in his case, when he wanted to look into previously existing data in the ESS, on this case, there are three main processes that we have here. They started in the composite laminate process that's being done by his colleague. They started with a stack prepreg as an input to produce this composite laminate. And what they do with that is they do several testing, basically to cut this composite laminate into smaller pieces to conduct some experiments on it. Some more details. There are different type of testing that that they do on the sample, as well. It contains a few curing steps in the previous process, and in the more abstract layer, each of these process have certain device that attach to it. What is being used to actually produce this data, or to conduct certain steps, and which project that actually attached to it. We have it online, so if you're interested, you can go there and check what is inside. But I just will show you some screenshot here. This would be what you will see when you start going to this page. And for example, Rodrigo wanted to browse this the first object, like first stack prepreg. All the data in here is computer generated, so apologize if the name doesn't make sense or the value is probably a bit off. So in here, when you first Rodrigo first look into the ESS, then he will search for a certain object, and he will be able to see what kind of information that that this object has, like the thickness, the type, amount of layer, and so on and so forth. important is that this is something that's being used for input for this certain process, this shaping and curing one. This is the composite laminate that's being produced by this process, this shaping and curing one, and it already has a different property on it. And then in the next process, they will cut this into several pieces, like this, like the three output that's being produced by the cutting process. And then I will go to the one example of it is one sample that's being generated, and this is what will be used by the ILSS testing. Don't ask me about the ILSS. I don't know much about it, but this is what is the value of it and all the information that's being contained within this object. So having this in hand prevent him not to be able to browse the data due to the lack of knowledge about the technology. This will help him to browse existing data that's already standardized by the use of ontology. This is another case about alloy analysis. If I understood it correctly, this is something that will be explained by our colleague and Sitef in the next session. Well, what I understand from here is that you have an alloy and you do imaging of an alloy with the different kind of setting with certain microscope, and you will produce an image. Then the image will be used to calculate the precipitation of this alloy component. Again, example of how does it look like when you go there. This is an example of one alloy, what kind of information that is contained, the percentage of the component, and this then will be an input for the imaging process to produce certain image. This is one example that you can actually show an image of the object itself. Again, this is just an example. You can have different thing inside. And this image then will be used in the next step to produce this precipitation statistic. For example, it has this number of densities 755. I'm sorry if it doesn't make sense, but it's just an example. Good. That's like the two cases where I can explain to you what how this is being used. Just briefly through the architecture and technology of the ESS itself, we have three parts of the ESS. The first one is on the right side. You can see like this is the one that you interact with. I start with the C. So where you actually go to the website, you can search for something, and then this is what being shown to the user. The second part is where the magic happens, where it's the logic of the processes, how it process the keywords, how it get the related object, how it interact with the knowledge graph data. This is on the second part, and in the third part is actually where in the preparation stage. So when you already have an ontology, when you already have the knowledge graph, the data that's contained within, you can then use it to instantiate and start the process on the right side. That's in a nutshell. Just a few words. So for the ESM, this microservice, we are using Spring Boot, RD4J, and Tinkerpop, while for the search interface, we are using this tool libraries, React.js and Redux. For further, if you have any inquiry about the technology, please feel free to contact us. The last part is about the guidelines. So if now you already seen this and you are interested to use it, we already provide you with the link where you can actually look into it, and then you can go browse and then use it already to instantiate your own ESS in your own innovation case. We have two setup. The first one is basic. Basically, you need to have a few software as a prerequisite, Docker, Go, and Python, and then you can load your knowledge graph in a turtle file or a different kind of serialization and use that to start an ESS. But if you just you want to have more control over what's being shown to the user, what kind of thing that you can see in the GUI, then you can go for advanced setup, where you, for example, can define this user perspective. How many user perspectives that you want? Translator, guest, additional thing, I don't know, engineer, project manager, and each of them may have different type of UI to work with. Some other things like the widget definition is something that you can use for customizing the info boxes, what kind of thing that you see on the right side, or what kind of things that you actually can see in the related object section. So you can use it to customize the logic of the ESS. Okay, that's more or less what I wanted to say about ESS. Just a few takeaways. The first one, exploratory search, and ESS help user to interact with ontology and knowledge graph to make it less daunting for them as a starting point. This is important, not to scare away people, but to encourage them to use it, and later on probably they would like to know more and learn more about the technology. The second point, we already developed this ESS in the as part of OTE, and we applied it in several innovation cases. So you can see that there is some example already on how to use it and where to use it. And the last one, we already also provide you with a guideline to apply ESS in your innovation cases. And in case of question or you have difficulties, feel free to contact us so then we can help you with this. Thank you.